Newton's first law states that a body will remain at rest or move with constant motion unless acted on by a resultant force. So let's say that there was a car and the frictional force of the car was equal to 8 newtons. What would the driving force be? Well, the driving force, since the car is moving in a constant motion, there's no resultant force, meaning that the frictional force and the driving force must be balanced. So the driving force would be 8 newtons. Newton's second law states that the resultant force on an object is directly proportional to its acceleration. This can be expressed as F is equal to ma, where F is the resultant force expressed in newtons, m is the mass expressed in kilograms, and a is the acceleration expressed in meters per second squared. The relationship between the acceleration and the force is directly proportional. So say for example, the force applied is doubled, then the acceleration would also double. Now, an unbalanced force acting on a body means it experiences a resultant force. If the resultant force is along the direction of the motion, it will accelerate or decelerate the body. However, if the resultant force is at an angle, the direction of the body will change. Let's look at an example to better understand this. Now, a 3 kilogram object is placed on a frictionless horizontal force. A force is applied to the object, resulting in an acceleration of 4 meters second squared. The force is then maintained, but a second object with a mass of 2 kilograms is placed on top of the first object. The two objects are now moved together. First, let's determine the force applied to the 3 kilogram object initially. So we can use the formula for Newton's second law, which is F is equal to ma, which would give us F is equal to 3 times 4, which is 12 newtons. Now, calculate the acceleration of the combined system when both objects are moving together. So if both objects are moving together, we must add their masses, which will be 3 plus 2, which is equal to 5 kilograms. Now, we can rearrange the Newton's second law's formula for A, which would be A is equal to F over m, and we can plug in force we found in part A, and we can plug in the mass, which would be A is equal to 12 over 5, which is 2.4 meters per second squared. Explain how the addition of the second object affects the acceleration of the system in comparison to the acceleration of the 3 kilogram object alone. Well, the addition of the second object increases the total mass. So for the same force applied, the acceleration decreases, since acceleration is inversely proportional to mass when force is constant. Now, for D, if a constant frictionless force of 8 opposes the motion of the combined system, calculate the net force acting on the system and determine the resulting acceleration. So net force be equal to the applied force minus the frictionless force, which would be equal to 12 minus 8, which is equal to 4 newtons. Now, using this same formula from part B, we can simply plug everything in, but F is now equal to 4, which would be A is equal to 4 over 5, which is 0.8 meters per second squared. Newton's third law states that every action has an equal and opposite reaction. Now, forces arise in pairs, so if object 1 exerts a force on object B, then object B exerts an equal and opposite force on object A. Now, these pairs must be the same type of force, the same magnitude, opposite in direction, and on different objects. Now, let's say there's a book on the table. There's the normal force and gravitational force. Since the book is stationary, the forces must be on equilibrium. Now, this would be a case of Newton's first law and not Newton's third law, since the forces are acting on the same object, which is the book. Now, say a person is walking. There will be two forces that's exerted. There will be the applied force by the foot, and there will be the reaction force by the ground. Now, Fr is the force exerted by the ground on the person, pushing them forward while walking, and Fa is the force exerted by the person on the ground. These forces are acting on different objects, therefore it is a case of Newton's third law.